my name is Molly.
Hi, my name is Tammy. I'm Tiana.
We're all 13 and we're all year 9s at Ngātamariki High School. We are doing a bridge design project.
Here it is.
We were all in the bridge building competition in which we had to make a bridge that spans 700 millimetres out of limited resources. These were balsa wood, string, cardboard tube and glue. We then documented the process that we went through so we can improve. So, our hypothesis is we think that having a laminated beam will be stronger than just a plain square piece of balsa wood. Our problem was that it was really hard to cut a piece of balsa into 3 neatly. We eventually found a way by using the 3D printer to create a device which the wood slides through with blades to slice it into 3.
To prove our hypothesis, we made 3 beams. Just a solid piece of wood, a laminated beam, and a solid beam with 2 split pieces on each side. We tested these 3 by hanging weights off of them. Out of these 3, the laminated beam was strongest, proving our hypothesis correct. Our second problem we had was that the gluing the 3 pieces back used a lot of glue and we only get a limited amount. To fix this problem, we used a small amount of thinners to stretch out the glue and make it go further. Now that we know that a laminated beam is strongest, we made 2 beams, 10 split pieces on top of each other, 6 split pieces on top, with 2 on each side. This beam here was very wobbly and kept tipping over. This beam here held the most weight. Both of these have the same amount of wood and use about the same amount of glue.
Next, we used a bridge building website in which we made different bridge designs such as half arch, half truss bridge, a plain truss bridge, an arch bridge, a camelback bridge, and our final design, an inverted suspension bridge.
This was my first test bridge that we tested and held 50 kilos. This was my second test bridge, which held 55 kilos. It would be useful to know which parts of the bridge were under compression and which were under tension, and how much. Our idea is to include electronic sensing to measure this. This is how we came up with the idea to use a piezo element.
When the piezo element flexes or moves, it lets out an electronic charge. Our idea is to place the piezo elements where the bridge is under a lot of stress. We then connect them to LED lights which have a reaction depending on how much stress the piezo is experiencing.
We made a cradle with the 3D printer which holds the piezo. The cradle will then be placed on the parts we think are under stress.